Welcome to The Explainer. Today, we are going on a journey to meet the true heavyweights of the cosmos. Galaxies so enormous, they make our own Milky Way look like a grain of sand on a cosmic beach. So let's start right here, at home, in the Milky Way. It's this incredible collection of up to 400 billion stars, gas, dust, dark matter, all held together by gravity. Our entire solar system is just one tiny, tiny speck inside of it. And it is huge. Our galaxy is about 100,000 light years across. A light year, remember, is the distance light travels in a year. That's nearly 6 trillion miles. So to get from one side of our galaxy to the other, you'd have to travel at the speed of light for 100,000 years. It's a scale that's just really hard to wrap your head around. But here's the thing. What if I told you that our home, as massive as it feels to us, is just our starting point? What if, on the cosmic scale, the Milky Way is actually just kind of average?
Okay, so to really appreciate these giants, we first need to know what we're looking for. Think of this as a quick field guide to the 4 main types of galaxies you'll find out there in the dark. First up, we have elliptical galaxies. Now, these are often the biggest and the brightest of the bunch. They're like these giant, glowing cosmic footballs, usually packed with really ancient stars.
Next, you've got your spiral galaxies. And yep, that's us. Our Milky Way is a spiral. They're famous for those beautiful, iconic arms, which are basically just bustling nurseries where new stars are being born all the time. Then there are the lenticular galaxies. The easiest way to think of these is like a cross between an elliptical and a spiral. They've got that central disk shape, but they've run out of most of their gas and dust, so they don't have those bright star-forming arms. And finally, you have the irregular galaxies. The name pretty much says it all. There's no defined shape here. They're often just a chaotic mess, usually because they've been in a gravitational tug-of-war or even a direct collision with another galaxy. All right, now that we've got our guide, let's start the tour. It's time to see how our Milky Way really stacks up against the true giants of the universe. Our first stop is a long way from home, 212 million light years to be exact. This is the Condor Galaxy, the largest spiral galaxy we've ever found. And that incredible shape, it's being stretched out like taffy because of the gravity from a nearby galaxy. Just take a look at these numbers for a second. The Condor is over 7 times wider than our galaxy. I mean, you could line up 7 Milky Ways end to end, and you still wouldn't cover its full width. It's just huge. This is where the scale really starts to get wild. To try and put this into perspective, imagine if the entire Milky Way was shrunk down to the height of an average person. Well, on that same scale, the Condor Galaxy would be a 4-story building towering right over you. But hold on. Before we meet the undisputed champion, it's really important to understand that measuring these things is incredibly difficult. And what we think is the biggest can and does change as our technology gets better. Take the case of a galaxy called IC 1101. For about 30 years, we were pretty sure this was the king, with a mind-boggling diameter of 4 million light years. But as our telescopes and methods improved, that number shrank a lot. It's a perfect example of how science is always learning and refining what we know. But even with its new, smaller size, IC 1101 is still hiding something incredible. Its central black hole has the mass of 100 billion suns. That's believed to be the absolute physical limit for how large a black hole can possibly get. Just wow. So with that in mind, it is time. Let's meet the current record holder. Prepare yourself, because this is the heavyweight champion of the known universe. Our final destination is 654 million light years away. This is ESO 38376, a giant elliptical galaxy that got this big the old-fashioned way, by spending billions of years swallowing up its smaller neighbors. So how big is it? Its diameter is a staggering 1.8 million light years. Let that sink in. A beam of light, the fastest thing in the entire universe, would need almost 2 million years just to get from one side to the other. And if you think that's hard to grasp, let's talk about volume. You could take our entire galaxy, the Milky Way, and fit it inside this thing. 8,000 times. 8,000.
Let's go back to our human scale analogy one last time. If the Milky Way is you and the Condor Galaxy was a 4-story building, well, this champion, ESO 38376, would be a 12-story skyscraper looming over you.
So we've found our champion, but the universe has one final, profound secret for us. Because finding the biggest galaxy is one thing, but actually getting there? That's another story entirely.
And here it is, the final mind-bending twist. The universe is expanding. The problem is, the farthest galaxies are moving away from us faster than the speed of light. And that means a shocking 94% of the galaxies we can see in our telescopes are already forever beyond our reach.
Think about that for a second. The light we see from them left billions of years ago. We are literally watching ancient history play out. And we are completely fundamentally locked out of ever exploring the vast majority of our own universe. And that leaves us with one final, humbling thought. We've toured the giants that we can see, but what other wonders, what even more massive galaxies lie out there in the parts of the universe we can simply never know?